How's it you were in Desert Storm? What is this?
I'll show you.
Looks like a hand grenade.
Yeah, I'll show you what it is.
It is a hand grenade?
No,
Oh,
but I will show you what it is. You see that electrical connector in there?
I don't think I've ever seen one like that. I've seen a lot of different kinds of electrical connectors that's got a whole bunch of pins.
Right. And at the other end,
The same thing. So it's an inline. What is it?
Okay. This will take a couple of minutes, but it's worth it. Interesting. This connector is unique. This connector set is unique. If I'm not disturbing you.
Not at all, no.
Yeah. I went to work with a company called Networks Electronics.
What kind of electronics?
Networks Electronics.
Networks Electronics.
Right. And my first task, I came into the office in the morning, and here's a little tiny computer about that long, about that high, and about that deep,
Okay.
sitting on my desk with one of these connectors, the connector by itself plugged in to the connector at the end of the box. The computer was made by Litton Data Systems for the Marine Corps. And a little note on it says, pull the connector out. Well, the connector has a coupling ring. You see this little coupling ring over here? If I'm disturbing you, let me know.
No, I see it. I can see it.
How can you see it and then be watching something else's?
No, because I'm looking at the screen. If anything, I could see it even better because it's zoomed in.
Oh, you are photographing me.
While I'm videotaping this, I could zoom in from a mile away and I could read the fine print.
Anyway, you see this little coupling ring here. You pull back on that and it collapses a spring inside that enables this 37-pin connector to be withdrawn. And the little note said, pull the connector out of the computer. And no matter what I did, I couldn't get that connector out of there.
It was stuck.
Yeah, there was some sort of a problem. And my problem was, my first job, as I went to work for this company, what the hell's gone wrong with this connector? I pulled out all the drawings and had all the bits and pieces in front of me. And it took me about almost 2 days to finally figure it out.
And what was it? How did you...
The problem was tolerances. When you have a set of drawings for a part, the machine part has dimensions on all the features on the metal part. And each dimension has something called a tolerance, plus or minus 1/1000th of an inch, 2/1000ths of an inch, whatever it is. That dimension has got to be held within that tolerance, otherwise the part's no good. So far, so good?
Yeah, I'm following you.
Okay, good. Well, I suddenly realized what the problem was. The problem was tolerance accumulation. Every so often, these plugs would go into the socket and they couldn't get it out. And they couldn't get it out because the tolerances on one or two facets of the part were working, but cumulatively the tolerances were such that it would build up to the point in a certain set of combination of parts that the spring inside that would collapse when you pull that coupling ring back would collapse in a way that would make it wind up, and you couldn't get the thing out with blasting powder.
Wow.
Okay, so I fixed the tolerances on the drawings, and the problem was solved. They built thousands upon thousands of these plugs and receptacles. These were custom plugs and receptacles, 37 pins. And they built,
That's a lot of pins, 37.
They built thousands of these connectors thereafter. and never had a problem again.
Because they got the tolerances right.
Yeah. So I was suddenly the hero of the day. Okay. And this was
Push to turn, switch.
yes, I will explain that. Okay, here was this computer designed by Litton Data Systems. Actually, it was designed for the Korean War. And the problem with the Korean War was mortars. You have an outfit out in the field in the jungle, and all of a sudden these mortar rounds would come in and cause them all sorts of problems. Where the hell were the mortar rounds coming from? Well, this computer system that the Litton Data Systems had developed was linked to radar and to artillery pieces. And the radar sensed these rockets coming in, and before the rocket had gone 100 yards, they had already tracked the arc to the origin of the site.
Knowing the trajectory.
Right.
Yes. No.
And before that round hit the ground, the artillery was firing on that site. That's what this computer did.
Oh, very interesting.
Yeah. Well, it turned out that this computer was very capable of many, many things, and the military found, the Marine Corps found many, many uses for this particular computer. But every time they had a new application, there was a new cable that had to be plugged in because the connections were different for the different application. Well, by the time Desert Storm came along, there were 16 different applications for that computer and 16 different cables. And they had 3,000 of these computers times 16 cables. That's a hell of a lot of cables to haul around. The logistics was a problem.
Huh.
So what they did was to select out the 4 most common uses for that computer, and they took the 4 cables and designed a special cable which they plugged in to the back end of this design. And then what you did was a 4-position selector. Here, look. 4-position selector.
Digital voice, your finger's covering it now. Digital voice, don't tell me. Hold it right. They'll turn it a little bit like you had it. I was able to see it. Digital voice, turn it the other way. No, the other way. Okay, there it is. Digital voice, TAC fire, and W2.
Those were the functions. And in order to select, you had to push this thing in, and there were 4 positions. Those were the 4 functions. So one cable served 4 functions. All right?
Which reduces the amount of, like you said, it was an insane amount of cables and
Okay,
functions.
now the problem was, it had been my experience over the years that when the military wanted something, they would come up with a specification for what this something was supposed to do. How it would do it, that would be up to the people who are going to build the product. And they sent out requests to bid. And the low bidder got a shot at building a prototype. And if the prototype worked out, then they would get the contract.
Makes sense.
Right.
Yeah.
Okay. This was for Naval Air Warfare in Indianapolis. And for the first time in my experience, the guy who was ordering this from Naval Air Warfare thought himself a good enough engineer that he could design this himself. And what he designed was an absolute ball of snakes. All right? The bits and pieces could either be made by machine, CNC machines, or you could do castings. But the problem is, the only time you'd use castings to make these parts is if you were building something like vacuum cleaners or something like that you're going to build millions of. And there were only 3,000 of these to be made. Well, he had designed all the parts as if they were to be castings, okay, which was ridiculous. It would have been millions of dollars in tooling to build this 3,000 sets of parts. Made no sense. And you couldn't, as he had designed them, these parts could not be machined. They would have to have been redesigned for machining, for a CNC machine, to do the same function. At any rate, we would send we were required to bid on his design. Well, his design couldn't be made by a machine tool. And we would send these drawings out to be bid by our machinist suppliers, and they all came back no bid, no bid, no bid. Well, we couldn't honor the position to bid on this unless we used his drawings. Now, you could design your own product if you wish to do this function, but you still had to submit a bid on his design as well as your own, which is absolutely idiotic. I'd never seen anything like this before. At any rate, I finally had to go out and to these shops. They all came back no bid, no bid. We went to the best of them and said, submit us a bid on these parts with the promise that we will never order the parts. That way we could bid on the thing, okay? At any rate, I sat down and designed not only this mechanism, but the selector switch, 6-pole, 12-position, 12-pole, 6-position switch on the inside, which is manipulated.
Wow.
Okay.
Yeah.
And they themselves had gone out to get bids on a custom switch that would go inside here. And the best bid they got was $250,000 and 6 months to prototype.
Too expensive and takes too long.
Right. So I designed the switch that is in here, very simple switch, consisting of a plastic tube with buttons all around the outside.
You probably could have got a patent on it.
And finger contacts on an outer insulator sleeve that shorted pins as you rotated it and made the electrical connections. That was my 12-pole, 4-position switch that is in here.
I think you could have got a patent on it if you guys attempted to apply for a patent.
I designed this, and this thing had to meet military requirements. Shock, vibration, salt spray, you name it, they threw it at us. How they missed nuclear detonation and RF radiation, I don't know, but they didn't require that. But this switch had to work under 6 feet of water. At any rate, I sat down and designed the thing, and we quoted this as our design at $900 a pop. 950 actually. The one we quoted for them of their design, we quoted $1,500. We're praying to God they'd never order it because nobody could machine those parts. At any rate, I designed this thing. This was the first time in my life I'd had an opportunity to do this. Sit down, design the part from ground out. Every bit and piece in here was designed by me. I did the drawings, I did the specifications, I did the test reports, I did everything that was necessary.
You had the prototype created.
And when the parts came in...
Tested it, it worked, it did what it was supposed to do.
Right, and then I had to design assembly fixtures because there were ways that you had to put the thing together. You'd need 2 hands and 15 fingers to hold everything in place while you were doing this. So I built fixtures that made it simple to just put the parts in the fixtures and close it up, and there your assembly was done. The interconnection wiring inside was done with printed circuits. Okay? Now his design originally, this whole thing, cable and all, would turn. Well, that meant that the wiring inside was doing this kind of dance. going, well, how long is that going to last in a military war zone application? I mean, it's terrible. It self-destructs. Anyway, we built 3,000 of these for the Marine Corps. And it met all of the standards and all of the operational functions.
And you sold them for $950
right.
a piece.
It was a $3 million contract that we did.
And you made a decent profit, which you deserved,
The contract made $1 million for the company, the most profitable product they had ever made. As a joke, I told my boss, after all the work that I had put in on developing this thing and documenting it and everything else, I said I ought to get about a 5% commission on this. And I was joking. Okay. Anyway, the check came in from Naval Air Warfare, and my boss comes into my office one day and he starts piling up weekly paychecks after weekly paychecks after weekly paychecks until they added up to $20,000. That was my bonus.
Nice.
This was the most successful design and the most successful product I'd ever built in my life, and it was the only product that ever fit my wish to take a product from concept and write up and design and detail and document, and I even machined some of the prototypes, bits and pieces.
And I'm guessing you only have that one piece.
This is the only piece that I have. This is a copy of. This is an actual Naval Air Warfare.
It's definitely something to be very proud of. I'm not surprised that you've kept it all these years, because that's not something that you would throw away.
I had one. I thought I had put it away someplace, but I was never able to find it. Well, the company recently went out of business, and the people sent me all of the documentation and bits and pieces around the plant as they were closing up the plant that related to me or anything like me.
And you have these here somewhere, probably on a bookshelf or somewhere over here.
And they included one of these.
Oh, so they sent you the one.
Right.
So that's the only reason you have that one, is because they were nice enough to send it to you.
Right. Now, if you have a copy of Adventures of an Apple Founder.
Of course, yeah.
Which I published 13 years ago.
Is there a picture of that,
and
I think?
in there's a photograph of this device.
Yes.
It went to Desert Storm.
The first Desert Storm, the first Gulf War.
In 1990, yeah.
Yeah. Wow. Very impressive. You never told me this story before.
The high point of my engineering career.
Well, that's something to be very proud of. I can see why it probably brings back a good memory. You were probably very proud of yourself and very pleased that it worked out as good.
Well, I told you that I had so much fun working for 16 years at Thor Electronics.
You'd be there on a Sunday, and the boss or the owner comes in and says, "What are you doing here?" And you tell him, "What do you want me to do? Sit at home and listen to my arteries clogging?" And I used to do that too for the big company I worked for, Figgy International. It was not uncommon for me to go in on a Sunday or Christmas Day or something.
7 days a week. Holiday Sundays.
And you weren't asking for any extra overtime or money. You just
I was on salary.
Yeah.
I was having too much fun.
Very interesting. Well, with that, I'm going to end this so I could play you a few seconds, but you'll see what a good video. This brand new iPhone 16 Pro Max with 1 terabyte of internal memory. The most expensive, highest quality iPhone Apple ever sold. A terabyte
is quite a lot.
Yes, it is.